What specific problem does activated LoRA, aLoRA, aim to solve in the context of fine-tuning large language models? And what limitations of the traditional LoRA approach does it address?
Activated LoRA, aLoRA, aims to solve the inefficiencies associated with switching between multiple LoRA configurations in multiturn interactions, where recomputing the representation of all tokens prior to generation introduces significant latency and computational overhead. Traditional LoRA requires the entire context to be pre-filled using the LoRA model, which is inefficient and can degrade performance on tasks best handled by the base model. aLoRA addresses this by decoupling the adaptation process from the need to recompute the input's representation, allowing for instantaneous switching between specialized models while reusing the base model's KV cache. This innovation not only reduces computational costs, but also enables a more modular approach to task-specific behaviors, overcoming the limitations of traditional LoRA that necessitate complete retraining to incorporate new capabilities. Overall, aLoRA enhances the adaptability and efficiency of fine-tuning large language models in dynamic environments.
How does the proposed activated LoRA method work? Please illustrate its mechanism step by step, particularly in how it interfaces with the KV cache during inference.
The activated LoRA, aLoRA method operates by adapting the attention weights of a large language model, LLM, while leveraging the existing key value, KV cache, to enhance efficiency during inference. First, aLoRA modifies the attention weights W_Q, W_K, and W_V by adding low-rank matrices delta_Q, delta_K, and delta_V only for tokens that occur after the activation sequence is invoked. This means that the weights for tokens generated or pre-filled by the base model remain unchanged, allowing the model to reuse the pre-computed KV cache for those tokens, thus avoiding the need for recomputation. When the aLoRA model is activated, it processes the input tokens that follow the invocation sequence, adapting the weights for these tokens while still utilizing the KV cache from the base model for the preceding tokens. This design allows aLoRA to maintain its own KV cache for newly generated tokens, ensuring seamless transitions between the base model and the adapted model without incurring significant latency or computational overhead. Overall, aLoRA's mechanism enables rapid switching between specialized behaviors while preserving the efficiency of the base model's inference process.
Can you provide a simple yet illustrative example of how aLoRA would be invoked in a multiturn interaction scenario? Walk through the key steps and data involved in this example.
In a multiturn interaction scenario, aLoRA can be invoked by using a specific invocation token sequence that triggers its specialized capabilities. For instance, consider a user query that requires the model to assess answerability based on prior conversation turns and supporting documents. The key steps would involve 1. The user sends a query, which is processed along with the conversation history and relevant documents. 2. An invocation sequence, such as less than start underscore of underscore role greater than answerability less than end underscore of underscore role greater than, is appended to the input to signal the aLoRA model to activate its adapted weights. 3. The aLoRA model then utilizes the pre-computed KV cache from the base model for tokens generated before the invocation, ensuring efficient processing without recomputing the entire context. 4. The model generates a response indicating whether the query is answerable or unanswerable based on the provided documents, leveraging the specialized weights for the tokens that follow the invocation. 5. Finally, the output is returned to the user, seamlessly integrating the aLoRA's capabilities into the ongoing conversation while maintaining the context from the base model. This process illustrates how aLoRA enhances multiturn interactions by allowing rapid switching between specialized behaviors without incurring significant computational overhead.
What are the theoretical and practical benefits of using the aLoRA method compared to standard LoRA implementations, particularly regarding computational efficiency and performance in dynamic tasks?
The activated LoRA, aLoRA method offers significant theoretical and practical benefits over standard LoRa implementations, particularly in terms of computational efficiency and performance in dynamic tasks. Theoretically, aLoRa decouples the adaptation process from the need to recompute the input's representation, allowing for instantaneous switching between specialized models without the overhead of recalculating the key value, KV cache, for prior tokens. Practically, this results in reduced latency and computational costs, as aLoRa can reuse the existing base model KV cache while maintaining its own cache for newly generated tokens. This modular approach enables seamless integration of task-specific behaviors within complex workflows, enhancing the model's responsiveness in multiturn interactions. Empirically, the performance of aLoRa remains comparable to that of standard LoRa, achieving similar accuracy while providing significant runtime benefits, particularly in scenarios requiring rapid transitions between tasks.
How was the activated LoRa method validated in your experiments? Please describe the datasets, benchmarks, and performance metrics used to assess its effectiveness.
The activated LoRa, aLoRa method was validated through experiments using various datasets and benchmarks, specifically focusing on intrinsic tasks such as uncertainty quantification and answerability determination. For uncertainty quantification, the model was trained on a diverse set of benchmark question-answering datasets, applying the UQ calibration method to generate certainty scores. In the answerability determination task, the model was evaluated on two benchmarks: the single-turn setting, squad-run benchmark, and the multi-turn setting, MT-RAG benchmark, assessing its ability to classify queries as answerable or unanswerable based on provided documents. Performance metrics included mean absolute error for certainty scores and classification accuracy for answerability tasks, with results indicating that aLoRa achieved comparable or superior performance to standard LoRa models while maintaining significant runtime efficiency. Overall, the experiments demonstrated that aLoRa does not lose performance relative to LoRa, achieving the best classification performance on the squad-run benchmark.
What were the results achieved with the aLoRa method in terms of performance metrics, and how did these compare specifically with standard LoRa models?
The results achieved with the activated LoRa, aLoRa method demonstrated that its performance metrics were largely unchanged compared to standard LoRa models, indicating that aLoRa does not suffer from significant performance degradation. Specifically, in the evaluation of answerability classification, aLoRa achieved the best classification performance on the squad-run benchmark, while maintaining comparable performance to LoRa across various tasks. Additionally, in the query rewrite evaluations on the MT-RAG benchmark, both aLoRa and LoRa exhibited performance within a point or two of each other, suggesting that the transition to aLoRa for efficiency does not compromise effectiveness. Overall, aLoRa provides significant runtime benefits without sacrificing accuracy, as evidenced by its performance metrics being on par with those of standard LoRa models.